Welcome to Bungalows for Bachelors. We are going to design some beams today, and we're going to do it fairly quickly. If you have any questions about how I'm moving through some of these things and I go too quickly, then you can either rewatch, rewind, or go back to some of the other designs and take a look at how I am getting the numbers that I'm getting. The biggest thing being understanding tributary widths for beams here. So, that said, we are going to jump right in and we are going to calculate some beams. The first thing I'm going to do is I'm going to pick a beam and I'm just going to get started. I'm going to start on the top. I'm going to start up high and work my way down through the building. The other thing I need to do is notate where I have concentrated loads going down through my walls so that I can make sure I catch those with either beams or special things. So, to do that, I'm going to create a circle here, like that. I'm going to copy it and paste it on the ends of all my beams where I have concentrated weight coming down through my wall, and you will see what I'm going to do in a second with these and why. These are points of interest for my first floor. And we have to check this because anytime you start concentrating loads, you need to make sure they get down to the foundation through solid wood, basically. All right, so those are the ends of all my beams where they're sitting on walls. So I'm now going to try to select multiple. And if you can't do this, if you're doing this on paper, then, basically just eyeball it, measure it. It'll be a little slower, but you can do the same premise. Figure out where the loads are on the first floor, on the second floor. Oh, shoot, now I got to start over here. All right, so you got to figure out where they are on the second floor and just use dimensions and things to bring those loads down to the first floor. And draw them on there so that you can see, oh yeah, I've got weight coming down here. All right, so I've got them all now. So now what I want to do is I want to move them. So I'm going to find a place that this guy was in this front corner here. So I'm going to keep him in mind and move him to the appropriate place. He was right here on the other floor. Okay, so the first thing is that I can think about is anything that's in the wall, I can pretty much forget about, but I'll leave the dot on there to remind me when I'm framing that, oh yeah, I have a special thing here. And anything that is not on a wall is going to be something to keep in mind when we're designing those beams. So for example, there's a load right here in the middle of the floor. Now, look at the beam it's coming from. It's this little thing. There's not going to be that much weight. So maybe doubling 2 joists is good enough, but the fact of the matter is that there's now more weight there and it's concentrated, so we need to check it out. And we are going to do this. Oh, that's not what we're going to do. We'll just copy paste. No, that's not what I want to do either. Okay. All right, so now we need a beam underneath this. So we're going to put a beam in and catch that. Same thing right here. There's nothing catching that, so we need to make sure we have something in there to catch it. All right, anything that lands in a wall is fine because it's just going to get studs. That one is not landing in a wall, so it needs something. Now notice here what's happening. Sometimes things come down on door headers. So we happen to know that that's a particularly special door header, and we need to design this door header. We need to keep this in mind and design this guy. We will also now need to design this guy because we have a special load coming down. We can't use average numbers and things like that. All right, that one's coming down on the wall. I think everything else is okay. Yeah, everything else is coming down on the wall. So we had 3 new beams we had to add here to catch these concentrated loads from the floor above. So we are going to, now that we got that taken care of, we're going to start designing. All right, so first primary bedroom, let's do this up here. All right, so the way you do this is you want to start with the beams that are the lightest, or the ones that are not being loaded by other things, because what's going to happen in the software is once I design this, I can add its load to this new beam I'm designing without having to do any extra math. I just say that it's connected right here and I'm good to go. So that's how that works. All right, so this guy right here is going to be primary bedroom, front to back, rear, because there's 2 front to back beams in the primary bedroom. So we'll do that. One end's on the wall, one end is on a hanger. What is it holding up? Well, this is a flat ceiling right here. So ceiling joists are going to go left to right, so it's going to be holding some width of ceiling. And on the roof plan, this is right where that roof pitch happened. This pitch change happened from the dormer. Let me show you that real quick. Oops, wrong way. It's right where this happens. So what we're going to do is we're going to take the width of this guy, and it's going to be our tributary load, tributary width for the roof loading. So let's go back and do that real quick. Let's go into Forte. So first things first, drop beam. This is primary bedroom, front to back, rear. All right, code minimum, leave all these settings alone. Spans and supports. Let's go back to our drawing. And what I'm likely going to do here is continue to move quickly, because there's a lot of beams to do in here. We don't want this to take forever. It's about 3'9". Great, so I'll go back. I'll put in 3'9". And I'm on a wall with blocking. I'm good. And the other one is a, not the bottom, it is a face mount hanger. It doesn't really matter which one super badly. Face mount hanger on a beam, because there's another beam holding it up. And that beam, I don't know what it's going to be made of yet, but I'm going to assume it's commodity lumber because it's not doing a lot of work. So I'm going to go back and say it is a, southern pine beam. And that's it. Okay. Top edge, bottom edge. What I'm going to do is I'm going to go end supports only for a lot of these beams, because I don't want to have to think about it. And this is being conservative, and it's faster. And it really doesn't matter for short beams that are not huge. Okay. Loads. All right. Let me hide this guy. So I have ceiling and I have roof. So I'm going to go back to my drawing, and I'm going to say, what is the tributary width of the ceiling I'm responsible for? Halfway there to there. Halfway from here to the wall where the ceiling is held up. 5 feet. Great. So I will say 5 feet on top. This is not super important. I'm just kind of averaging, saying it's on top. There's no crazy side loads. Ceiling, no attic, is going to be 5 and 10. And this is going to be ceiling. Okay, then I am going to add a load. Uniform, pounds per square foot, whole length. Tributary width, let me grab that from my drawing. Oops. Need to go to the roof that I saw. Make sure this is to scale, which it is. Halfway from the wall to there. Halfway to the ridge. 5'3". Okay, so let's say 5.5. 5.5 feet on top. Dead load of roof is 10 and 20. Okay, and there's a roof slope. Okay, we're going to check the plans for the roof slope. And it was a 10-12 here and a 3-12 here. We're not concerned with the difference in the 3-12. We're just going to say 10-12 and be conservative. A little bit extra weight, no big deal. All right, so we'll go to a 10-12 roof pitch. See how that raises the dead load effective? This is the roof. All right, great. Product selection, this is tiny, so I'm just going to assume 2 2x6s. 2 Southern Pine 2x6s. Solutions. And passed everything with a jiffy, no problems here. So I will go back to my drawing. And I will analyze the situation here. Delete this, get out of the way, clean it up. Okay. 2 by 6 Southern Yellow Pine number 2. Right there. Okay. There's that one. All right, let's keep going. Let's go ahead and do this front beam here and see what it's holding up. What is it holding up? Well, the ceiling's running left to right, so it's not that. And the roof's braced down to everything else, so it's not that. So why is it here? Well, it's here because its job is to hold up this little piece of gable that I was showing you here. Remember this? This piece of gable has to be held up by something. So that's what this beam is going to hold up. So I'm going to grab approximately the height of this wall, 4'5". We'll call it 5 feet. All right, so that's my tributary width because it's a wall. I'm going to go vertical. All right, so I got 5 feet along my beam of wall, which is about 8 pounds per square foot of dead load and no live load because we don't walk on walls. All right, so I'll go to my beams. I'm going to just copy here. This is primary bedroom, right, left, front, and spans and supports. I'm going to go check the span. Right here. Oh, there's a hanger on the left side, wall on the right side. Just good to note. 5'5", we'll call it 5.5. 5.5. This right side is the bottom. Stud wall. Spruce pine fir. The left side was the face mount hanger. That sounds good. And the beam material is probably southern pine. This is what it's hanging on is southern pine. Matters a little bit, but not a ton. Okay, the loads. Well, this didn't have any of these. So what I'm going to do is I'm going to do this one. And we had a tributary width of 5 feet. Placing it on top of the beam. That's great. Dead load 8 pounds per square foot for a hardy wall, exterior wall. There's no slope because it's just a wall. And no live load. This is a wall load. Product selection, I'm going to say the same thing because it's probably fine. And sure enough, this is barely loaded at all. 2 2x6s is more than sufficient. Also, this is not a copy. This is primary. Okay, so this beam is also good. So let's do that. Okay, I'm just going to copy this, paste it here, rotate it. Oh, rotate it a little bit back. Okay, boom. All right, so now let's do this this left to right one here. This is going to be primary bedroom, left, right, rear. And let me get the span while I'm here. 9'6". That's great. Primary bedroom. This is right, left, rear. Spans and supports. We said, I forgot already, 9.5 feet. 9.5 feet, and we are on wall to wall. So it's sitting on the bottom of a stud wall. Well, its bottom is sitting on a stud wall. And there's probably blocking on it, but that's not going to make a huge difference. Okay, what loads are we dealing with here? Okay, ceiling is running left to right. Not a problem. Roof is running left to right. Not a problem. Why is this here? It's here to catch this beam and define this edge for the dormer. So we're going to deal with maybe a little bit extra ceiling weight. We'll call it like a 2-foot tributary width of ceiling. And then this beam's going to load this spot right here. Well, where is that? 3'1". We'll call it 3 feet in. Oops. Okay, we'll say 2 feet of ceiling, which is 5 and 10. I'm saying that 2 feet because there's going to be a little bit extra weight from the stuff that's kind of attached around here to make this dormer. All right, so that's what I'm doing. It's just adding a tiny bit of weight for that. And then I am creating a point load. Sorry, not the way to do it. I'm linking a reaction from the primary bedroom front to back rear. Remember this hanger? See that hanger? That's hanging on this beam. So I'm going to select reaction 2. The location was 3 feet in from the left side of this beam, placed on the back side of this beam. transfer. See that? 3 feet in from the left, placed on the back side of the beam with a hanger, reaction 2 of this beam. That's how we do it. All right, linked in, loads are populated, good to go. What do we need? Let's see, maybe 2 2x8s. It's a decently longer span. We're bending and deflection's still fine. Let's see what happens if we did 2 2x6s. We're getting up to 87%. That's kind of high, and 2x8s aren't that expensive, so we're going to bump up the 2 2x8s for this guy, and everybody's going to be hunky-dory. Copy, paste. 2 2x8, Southern Yellow Pine number 2. Great, that one's designed. Okay, let's do this front one here. This one's going to be a little more complicated, but we can take care of it. This is going to be, let's grab the span while we're here. That way I can forget in a few seconds. 9'6", basically. Let's remember that. Let's try to remember that. All right. Sometimes it serves to copy different beams depending on which ones are similarly loaded, but that's being really specific. You don't really need to. This is like saving seconds when you have hundreds of beams to design all day long. Primary bedroom, front to back. Front. Okay, span and support was 9.5. That's good. I'm sitting on 2 walls. That's correct. End supports only. That's fine with me. Loads. Okay. Ceiling first. I'm holding here to here. Remember, that's the support point for the ceiling. So I'm holding here to about here. So if you're ever doubtful, just overestimate a little bit. 6'6". That's cool. 6'6". Do that. 6.5 feet of ceiling. Dead load. Live load's already correct, so I'm happy. I don't have this point load anymore. What I do have is this point load. So let's see how far that's in here. Remember, reading the plan starts reading from the right side of the sheet, looking this way. This is the left side of the beam. So about 3 feet in is this beam. So we'll go and link. This is right, left, front. Right, I can't quite read it. I think it is, yeah, right, left, front, because there's the hanger. All right, reaction 1, 3 feet in. Placement on the front side, transfer. Okay, so now we have the weight from the ceiling. We have the weight from this beam. What else is sitting on top of this? A bunch of roof braces. So how much roof area are we holding up here? Now, when you have a whole bunch of braces and it's like all in the same sort of pattern, you don't need to create a bunch of individual point loads. You just create an average tributary width and overestimate. That's much faster and, frankly, basically the same result. Okay, so we're dealing with these 2 ridges here. So we'll go back to here. All right, here's the blue ridge, here's the blue ridge. All right, so on average, what's happening here? This ridge is being supported from here down to that purlin line. This one's supported from here to this purlin, but the purlin's also sitting on the beam. Therefore, I'm going to just keep going. Okay, so this purlin is supported on the, this purlin is a support for the rafters, which the next one is over here on the wall. Okay, the rafter runs from the wall, supported by the purlin, and I'm basically responsible for all of the width across here. All right, so from halfway from purlin to wall is about there, and that's going to go halfway from ridge to purlin, which is about there. All right, so that's that tributary width, and then I have a different tributary width for the front 3 feet of this beam because the room changed. So I'm holding the ridge, and I got a purlin bracing on the beam too. All right, so I'm gonna go from the ridge to the wall halfway, and then from the purlin to the wall halfway. I'm responsible for this width of roof is being held up by my beam. So 9'1" something and 9'10". We're gonna do this. We're just going to do that. Okay, so the first 3 feet and the last whatever else of the beam are 2 different tributary widths of roof load. Okay, so let's go back. Create a new load. Uniform pounds per square foot, not across the full length. We want the first 3 feet. Tributary width of roof was And the first 3 feet was 9'1". We'll just round up to 9'2". On top, dead load of roof is 10, pitch of 12, roof live 20. This is front roof. Okay, and then I'm just going to copy this because it's a little bit faster. All right, instead of across the full length, we're going from 3 feet to the end. And tributary width changed to the 9'10". So 9 feet 10 inches. On top, all of this stays the same. This is back roof. Okay, there's all of our loads. Let's select a product. This is going to probably need to be a little bit bigger. Let's say 2 2x10s. Once you start holding the roof, things get kind of heavy. All right, let's say 2 2x12s. Still not good enough. 3 2x12s. Passed at 70%. Deflection's good. I like it. I can afford 3 2x12s, so let's do it. It's once you get into the engineered material that you kind of want to be a little more aware of what you're doing. That stuff's more expensive. So this was 3 2x12. Southern Yellow Pine number 2. Hunky dory. Okay, so there's that guy. Those 4 are done. Let's go back over here to this one. All right. For the purposes of speed, we're gonna split this into 2. I'm gonna design all the beams on the top in the first video and do the second floor in another video. Because this just takes so long. Okay. All right. So this little beam here is the bath. Is primary bath front to back, because there's only one front to back beam in the primary bath. Primary bath front to back. All right, what's my span and my support? 2 hangers and 4.5 feet. Let's say that's 4'4". We'll call it 4.5 feet. It's always better to overestimate. And I have a face mount hanger and a face mount hanger, probably on some southern pine beams. And supports only, that's great. Loads. Let's delete these and think about our beam here. Okay, so ceiling's running left to right. I'm responsible for the ceiling between the wall, the beam, all the way over to this wall, because this is all flat ceiling here. What's that width? It's about here to about here. That is 4 foot 10.5. So I'll round up to 5 feet. Of tributary width, top 5, 10, ceiling, good, happy days. All right. What about the roof? This is holding a little bit of roof too because of that dormer. So I'm going to go to my roofy plan right here. Okay. I'm holding halfway from here to the ridge. And I'm holding halfway from the ridge to the wall, or this change of pitch to the wall. Okay, roughly 6'7". We'll just call it 6'8". Can't hurt to round up. 6'8". On top, dead load of the roof is 10, pitch of 12, pitch of 10. Dead load of roof, roof live load is 20. Roof dead load is 10, pitch is 12. This is the roof. Product selection. I'm going with 2 2x6s because I think it's fine. 42% and no deflection problems. We're good to go here. So we will go ahead and go back and label our beloved beam with the old double 2x6s. Easy money. Okay, let's do these 2. Now, this is a very symmetrical thing here, so they're the same. I'm only going to design 1. So primary bath, left, right. And I'm going to just split this thing. All right, so primary bath, left, right. We're going to copy this first. Primary bath, left, right. Spans the supports. Okay, wall to wall is 6'3.5". Let's call it 6.5 feet. round up. Okay, this is bottom, stud wall, stud wall. This is not super important, by the way. If you're doing small beams, it's really not. Okay, blocking. But we're in the interest of being super correct, so fine. Okay, loads. There's no ceiling. These are parallel with the ceiling, so there's no ceiling, and there's no roof. All we're doing is linking the primary bath front to back. Either one of these reactions, because they are the same, because we had uniform loading on this thing. And it's pointing somewhere in this thing where? From the right side in, well, sorry, it dimensions in from the left in the program, so left side in is about 4'7". If you're going to be conservative in this location, push the conservative towards the center of the beam. The load moving towards the center of the beam makes the situation worse. So if you're going to estimate towards the center. So I'm going to say 4.5 feet. 4.5 feet on the front side is great. I'm going to say 2 2x6s because that's usually what's good enough. All right, 67% is fine. Deflection's fine. I like it. And I like making my life easy. Copy, paste, and paste. Naturally, when you're writing all this out, you'll make it easy to read, but I'm doing this for educational purposes, so I'm not going to read it. All right. Okay, here's this beam. This is going to be a bigger one. Let's check it out. This is going to be the den beam because there's only one den beam. Also, I am sort of putting these beams in the wrong categories because they're not in the first floor ceiling. These are in the second floor ceiling. So I will move them. And to do that, I will create a new level. Second floor ceiling. And I'm going to just grab it, drag it down, and fix my problem here. So we do this so that we can keep our beams organized and we know how to find them easily. And all that. So we are interested now in doing the den beam. So I'm just going to copy one of these. Call it den. Spans and supports. What's the span? What's the span? Oh, span, oh, span. From here to here. 13 foot 1.5. Okay, I don't want to get crazy conservative when I have long spans, so I'm going to say 13 foot 2. Let's go 13 foot 3 in case my measurement was a little off. Okay, wall and wall. Okay, good to go. How am I loading this? Okay, I'm responsible for some roof, clearly, and some ceiling. So the ceiling is going to go from the beam to there, and it's going to go from here to the wall. So let's grab half of that, and about half of that. 5'8", let's round up to 6 feet. We got 6 feet of ceiling, 5'10", great, everyone's happy. How much roof? Okay, so I'm responsible for this purlin, sorry, here's the pink. This is the purlin, bracing down to the beam. The purlin supported is, the roof rafters are supported here at the purlin and at the wall, so I'm going to grab that half distance. And they are, so now the rafters run up to the ridge. The ridge is supported to this wall, not my beam. So the ridge is actually, so that's where I'm done. The ridge is going somewhere else. So halfway from the ridge to my purlin is what I'm responsible for. 5'1", let's call it 5'3", just round up a little bit. 5'3", on top, 1020, it's all the same, great. Everybody's happy. It's got a longer span though, so I don't know if this is going to work. Let's try 3 2x12s. 93%, that's a little bit too much. 4 2x12s. I promise you 4 2x12s is way cheaper than 2 LVLs. So we want to try to use them. Okay, deflection's good, braking is good, no problems here. So 4 2x12s. Now in super long spans, the problem you run into is that 2x12s aren't as straight as long beams. So if you're after super straight stuff, then you probably should just switch to engineered lumber. All right, so I got 4 2x12s. Let's just grab this guy here. Probably could have used a different one, but that's fine. 4 2x12s, Southern Yellow Pine, number 2. Okay, oops, that's the purlin. It's going to be the beam right here. Okay, so there's all the beams for this floor. Let's end the video, and we will do the second floor later. Sorry, the first floor later.